Hello everyone. So I'm Tawdur Rahman. So I'll be today discussing about waste to energy production. An advanced engineering solution converting municipal and industrial waste into electricity, heat, and influential supporting sustainable urban development. So in the introduction, we can see rapid urbanization and industrial growth have increased the amount of solid waste generated every day. Improper disposal of municipal and industrial waste creates serious environmental and health problems. The challenge: rapid urbanization and industrial growth have dramatically increased solid waste generation worldwide, overwhelming traditional disposal system. The consequences: improper disposal of municipal and industrial waste creates serious environmental and health problems for communities and ecosystems. The solution: waste to energy (WTE) is an advanced engineering solution where waste is converted into useful forms of energy, electricity, heat, and fuel, helping manage waste efficiently while supporting sustainable energy production. So problem statement. In the problem statement, we'll see traditional waste disposal method like open dumping and landfilling create major issues such as environmental impact. Firstly, land on water pollution, bad odor and harmful gas emissions, greenhouse gas release, especially methane, public health risk. In the public health risk, firstly, we will see spread of disease and health risk, high on usage for landfill sites, wastage of potentially useful energy resources. So in the warning, we can see an efficient system is needed to reduce waste and recover energy from it. Why it is a complex engineering problem? So let's see, waste to energy is considered a complex engineering problem because it involves multiple interconnected challenges. First of all, waste diversity, handling different types of waste with different chemical properties. System design, designing safe and efficient energy conversion system, emission control, maintaining maintaining environmental emission standards, uh, cost management, managing high installation and operational costs, sustainability balance, balancing energy output with sustainability goals, regulations, meeting government regulations and public acceptance. It requires multidisciplinary knowledge in mechanical, environmental, electrical, and industrial engineering. So after that, we have project objectives. So let's see in the project objectives. First of all, reduce landfill waste, reduce the volumes of solid waste sent to landfills. Secondly, energy conversion, convert waste into useful electrical and thermal energy. Thirdly, reduce pollution, reduce environmental pollution and greenhouse gas emissions. Fourthly, public health, improve urban cleanliness and public health. Fifthly, renewable energy, promote renewable and sustainable energy sources. Sixth, circular economy, support circular economy and resource recovery. Proposed solution. So in the solution, we can see the proposed solution is to establish an integrated waste to energy plant that processes municipal solid waste through proper segregation treatment and energy recovery. So in this process, we can see first the waste collection and transport, and then waste segregation unit, then the recycling section, after that anaerobic digestion, uh, incineration chamber, then boil and steam turbine, and after that pollution control system, and after all of that ash management unit. This system ensures both waste reduction and efficient energy production with minimum environmental impact. So as we saw in the diagram, let's define that process. In the working principle, we can see how the system works. So first of all, the waste collection. Waste is collected from households, industries, and commercial areas using a planned transportation system. Secondly, waste segregation. Waste is separated into recyclable waste, plastic, metal, glass, organic waste, food waste, biodegradable materials, and non-recyclable combustible wastes. Organic waste treatment. Organic waste is sent to anaerobic digesters where bacteria break it down and produce biogas, mainly methane. Step 4, incineration process. Non-recyclable combustible waste is burned at high temperature in controlled incinerators. Energy generation. Heat from incineration and biogas is used to produce steam, which rotates turbines connected to generators to produce electricity. And step 6, after all, emission control. Filters and scrubbers remove harmful gases and particles before releasing clean air into the environment. Expected results. So in the expected outcomes, we can see 70 to 90% landfill reduction. That means reduction in landfill waste, 24 hours in 7 days power generation, continuous electricity generation from waste materials, 0% or zero methane release, significant reduction in methane and carbon emissions, cleaner cities and better sanitation, improved efficiency in municipal waste management, better resource utilization, better utilization of available resources, benefits to industry, society and industry. So first of all, we have to see the social benefits. Cleaner and healthier living environment, reduce spread of disease caused by waste, better public sanitation and hygiene, and renewable energy availability for local communities. Secondly, we have industrial benefits. So firstly, we have to see in the industrial benefits that reduced dependency on fossil fuels. So we don't have to depend on fossil fuels as we always have done. Uh, New employment opportunities in waste management. So it will create new job sectors, improved industrial sustainability. It will improve industrial sustainability and workability, long-term economic saving from energy recovery. This supports the development of smart, green, and sustainable cities. After all, the conclusion, waste to energy production is a practical and sustainable engineering solution for modern society. It solves two major problems at the same time, waste management and waste shortage. By converting waste into useful energy, cities can reduce pollution, improve public health, and support long-term environmental sustainability. Waste management reduces landfill dependency and environmental pollution. Energy production generates continuous electricity from waste materials. Sustainability supports long-term environmental and urban development. This project is highly relevant for future industrial and urban development.